Okay, so hari ni kita akan masuk chapter 6, which is dalam chapter 6 ni kamu akan belajar latch dan flip-flop. Okay, so this is another MS size lah. Okay, in the previous class, okay, kita dah belajar decoder, multiplexer, encoder, and then demultiplexer, 7 segment display and etc. for MSI circuit. Then next kita ada another MSI circuit called latches and flip-flops. Okay, so in this what we call here, in this chapter, okay, you will learn about the difference between combination and a sequential MSI, and then and then you will learn about the SR, gated JK. So this is for the latches lah, and then flip-flop. For the flip-flop, kita ada 4 jenis flip-flop, which is JK flip-flop, D flip-flop, and T flip-flop. Oh, sorry ya, kita ada 3 je. JK, T, and T flip-flop. Okay, and then we have a preset and clear function for the flip-flop. Okay, so this is the combination versus sequential logic overview. So digital circuit actually can be categorized into combinational and sequential logic circuit. Okay, kita boleh bahagikan dia kepada dua bahagian. Satu is a combinational and the satu is a sequential. Okay, and then the logic circuit, okay, can be divided into four families here. Okay, which is SSI, MSI, LSI, and VLSI. So each of these family, okay, boleh lagi dikategoriskan kepada combinational and sequential, combination and sequential, and all of these SSI, VLSI, LSI, MSI boleh berbahagikan kepada combinational and sequential. Okay, so apa beza antara combinational and sequential is, untuk combinational, okay, tiada output feedback, means that the output yang kamu hasilkan, that is a output. Kamu tak feedback dia ke menjadikan input. While for the sequential, okay, for the sequential digital circuit, this one here with a output feedback. Maksudnya output kamu tu, kamu feedbackkan dia supaya dia menjadi input semula. That is the difference lah between a combinational and sequential. Okay, so contoh combinational untuk MSI, okay, for this one is for the MSI is multiplexer, decoder, adder, demultiplexer, and then you have a encoder and etc. But for the sequential, okay, we have a latch and flip-flop. Hanya ada latch dan flip-flop aja yang boleh output feedbacks. Okay, dia ada output and then it feedback the output to the input. Okay, untuk dapatkan output semula. Okay, so let's look at the first sequential logic circuit, which is a latch. Okay, mula-mula kita nak tengok dulu latch ni macam mana bentuk latch, apa yang latch ni buat, and etc. Okay, latch is a type. Okay, so latch is a type of temporary storage device that has two stable state. Okay, so latch ni digunakan untuk kita temporary store a device lah. Okay, untuk temporary storage data. Okay, untuk latch it consists of two stable state, which is sometimes we call it a bistable, sama ada dia kosong atau satu. So that is a two stable states. Okay, so it is a basic form of memory, sama ada you going to store a value 0 ataupun 1 in a latch. Okay, so since it is a bistable, so the value for the bistable adalah hanya kosong atau 1. Latch are similar to flip-flops because they are bistable device that can reside in either of two states using a feedback arrangement in which the output are connected back to the opposite input. Okay, so latch ni sama juga, dia punya function dia sama dengan flip-flop. However, these latch are considered unstable in modern circuit and rarely used. So latch sudah jarang digunakan sekarang sebabnya dia tidak stable. So kebanyakan sekarang kita, untuk modern punya circuit kita akan gunakan flip-flop. Okay, so flip-flop are dominant sequential circuit element and are present in almost all digital system. Tapi even though the latch unstable and rarely used, tapi kita masih lagi kena belajar fundamental of latch, kerana daripada latch lah flip-flop terbentuk. Okay, so first kita akan tengok SR latch. Okay, latch ni ada banyak jenis latch. Okay, so first thing first kita akan tengok SR latch, and then we have an active SR latch. Active high SR latch. Kita ada active low SR latch and gated SR latch and etc. Okay, ada banyak jenis latch. Okay, so this is the, kita tengok dulu dia punya big brother dia kat sini. Okay, so SR latch. The SR latch, which is set and reset latch, is the most basic type which can be constructed using a NOR and NAND gates. Okay, so these latches boleh kita guna construct by using NOR, a combination ataupun NAND gate. So an active high input SR latch is formed with two cross-coupled NOR gate. Okay, kalau kamu nak buat active high input SR latch, kita kena guna two NOR gate that are cross-coupled. Okay, so this is an active high input SR latch. Okay, kamu tengok ni, kamu ada dua NOR gate. Okay, so this is the input. You have the one input, okay, label as a S. The second input label as a R. Lepas tu kamu tengok ni, this is the output. Output for apa ni? For each of this NOR gate. Okay, the first output kita denoted as a Q and the second one is a Q bar. Maksudnya kalau Q kat sini 1, this Q bar here will become 0. If this Q is 1 and this one is 0, and if the Q is 0 and the Q bar will be 1. Okay, maksudnya ni output untuk latch pertama dan output untuk NOR gate yang pertama dan NOR gate kedua akan complement of each other. Dia tak boleh sama. Okay, contohnya kalau sini 1, tak boleh. That is invalid. Okay, and then pada masa yang sama, okay, in the meantime, okay, because this one is a sequential, kamu tengok ni output dia ni, okay, output from the first latch, the first NOR gate here, masuk kepada, okay, become an input for the second NOR gate. Sekejap, saya kena angkat telefon dulu. Okay, minta maaf ya. Okay, boleh kita sambung semula. Okay, kat mana tadi? Okay, so sekarang ni, okay, if you see here, okay, the output from apa ni? The first NOR gate, okay, akan masuk kepada input of the second NOR gate. So this is why we call this SR latch as a sequential input, sequential logic circuit. Kenapa? Sebab kita feedback output become input. Okay, while the output for the second NOR gate here, okay, we feedback masuk sebagai input for the first NOR gate. Okay, so this is for the active high input SR latch lah. Okay, meanwhile, okay, for the active low input S bar R bar latch, okay, kenapa dipanggil S bar R bar latch? Because this is a active low input. So active low input ni maksudnya, okay, so dia punya input ni akan inverted. Okay, it's formed we have two cross couple NAND gate. Okay, every time you use the two NAND gates, okay, to make a SR latch. So this one we call it as a active low input S bar R bar latch. Okay, so sama juga. Okay, cumanya kedudukan dia input ni berbeza lah. Okay, for this one here, S bar kat sini, R bar kat bawah, and then this is the output Q, and this is the output Q bar. Okay, and then the output Q will become input of the second NAND gate, while the output Q bar will become the input of the first NAND gate. Okay, so kita akan tengok dulu. So this is the basic SR latch, active high and active low input latch. Okay, so now we are going to see the active high SR latch. So the active high SR latch has two input S dan R, which will let us control the output Q and Q bar. Okay, so this is the active high SR latch, which is we design it by using two NOR gate. Okay, so this is the first NOR gate and this is the second NOR gate. Okay, so this is the input R and the second one is the input S, and then okay, output from this NOR gate, okay, the first NOR gate will become the input of second NOR gate, while output of the second NOR gate will become the input of first NOR gate. Okay, here Q and Q is feedback into the circuit. They are not only the outputs, they are also become the and inputs. Okay, so to figure out how Q and Q bar change, okay, we have to look at not only the input S and R, but also the current value of Q and Q bar. So macam mana kita nak dapatkan persamaan Q and Q bar? Okay, so we can write something like this. Okay, first. Okay, kat sini. Okay, so for the first output here, yang ni Q ni, kita boleh tulis Q next, which is Q next, Q yang akan, next Q sama dengan, okay, so this is R plus with a Q bar current, okay, Q bar semasa, and then kamu not getkan dia. Okay, so this is the Q net. Okay, maksudnya Q yang akan next sama dengan R tambah dengan Q bar. So this is your Q bar lah, Q bar current. Okay, and then you have a NOR gate kat situ. Okay, meanwhile for the Q bar next, sama dengan, okay, input S tambah dengan Q. Okay, so this is your Q current. Okay, and then barkan dia. Okay, so this is the Boolean expression yang kita dapat lah. Okay, based on this logic circuit. Okay, so now by using this Boolean expression, kita akan carilah what is the value of Q and Q bar. Okay, bila mana R dengan S, okay, have the certain inputs. Okay, so first, what if S and R equal to 0? Okay, so sekarang ni, let's say lah, the first input is kosong, S kosong, R sama dengan kosong. So you put 0, 0. So what is the output of your Q? Okay, so since this one here, okay, since this is the persamaan, okay, yang kita dapat tadi, okay, Q net sama dengan R tambah Q bar current, okay, then you have a bar kat situ, okay, saya tulis kat sini lah, Qn is Q net lah, sama dengan R tambah Q bar N, and then you have a, okay, and then the next step is Q bar N sama dengan S tambah Q current. Sorry, this is QC, and then you, okay, so sekarang ni what happen is, sekarang ni R dengan S is 0, so you masukkan dalam persamaan, kosong, this one also kosong. Okay, when kosong tambah dengan Q current bar, so what happen? So kamu akan dapat kosong tambah dengan Q current bar, so kamu akan dapat ni lah, Q current bar. And then you have a bar kat sini, so bar, double bar, so you can cancel this one, so kamu akan dapat, okay, so it seems that Q and Q net sama dengan Q current. Okay, then for the second Boolean expression here, okay, kosong tambah dengan Q current, so kamu akan dapat kosong tambah Q current, and then you have a bar, and then jawapannya sama dengan QC bar. So maksudnya kat sini, Q next bar equal to Q current bar. So bila mana S, okay, bila mana SR sama dengan 0, 0, so Q next sama dengan Q current. Okay, what happen? Okay, maksudnya kat sini, whatever the value SKEU has, it will keep the value. Maksudnya kalau Q sama dengan 1, so the Q current sama dengan 1, the Q net is 1 lah. Okay, if your Q current is kosong and your Q next is kosong jugalah. So this is exactly what we need to store the value inside of the latch. Kenapa? Sebabnya Q kamu tak berubah, which is Q net equal to Q current. Okay, so every time you put 0, 0 to your S and R, okay, input S and R, so you know that you're going to store that value. Okay, you're going to do a data storing. Okay, kenapa data storing? Sebabnya Q net sama dengan Q current. Okay, kamu punya Q tidak berubah. This is for the S0 and R0 lah. Okay, and then we are going to see apa yang akan berlaku bila kamu letak S1 R0. Okay, what if S1 and R sama dengan kosong? So, kita nak tengok one by one. So, apa yang akan berlaku? Okay, so sekarang ni S kamu letak 1, R sama dengan kosong. Okay, so based on this expression, okay, yang kita buat tadi, okay, kita dapatkan kat sini. Okay, so kita masukkanlah dalam persamaan. So Q next sama dengan okay, R kita sekarang ni berapa? Okay, R is 0 tambah dengan Q current bar, and we have bar. Okay, so kosong tambah Q current bar, so kamu akan dapat Q current bar, and then bar you can cancel out. Okay, belum lagi, kita buat yang when S sama dengan 1 silap, saya tersilap, minta maaf. Okay, sorry, so padam dulu yang ni. Okay, kita ambil ya bila mana S sama dengan 1 dulu, and then kita dapatkan dia punya sama. Okay, so Q bar net sama dengan S tambah QC and bar. Okay, so sekarang ni since kita punya S sama dengan 1, okay, so kamu akan dapat 1 tambah QC bar, which is 1 tambah dengan QC, every time you plus with 1, kamu akan dapat 1 lah. Okay, and then 1 bar, apa yang akan berlaku? Kamu akan dapat kosong. Okay, so Q and bar sama dengan kosong. Okay, so this is the value. Q next bar, which is kosong. Bila yang ni kosong, so apa yang berlaku? Yang ni akan masuk ke sini. Okay, sebagai input untuk kamu punya NOR gate nombor 1. So once you put 0 kat sini, so what happen is kamu masukkan dalam persamaan yang ni tadi. Okay, so Q net sama dengan R tambah dengan Q bar current, and then you have a bar. So R kamu ialah kosong, and Q bar kamu pun kosong. Okay, kamu tambahkan dia, and then after that you barkan, so you will get kosong tambah kosong, you will get kosong. Kosong bar, kamu akan dapat 1. Okay, which is okay, so yang ni 1, yang ni kosong, which is betul lah sepatutnya bila Q, okay, bila Q kamu kat sini 1, Q bar mestilah kosong. So what happened here? Okay, so when SR 10, when you put SR sama dengan 10, then Q bar net is equal to 0 and Q next equal to 1. So this is how you're going to set the latch to 1. Okay, so every time you're going to set a latch, so you need to put this combination of input lah. S1, R0. Okay. Okay, so this is how you're going to set the latch. Okay, next. Tadi kita dah tengok to store to set, and then now we are going to see what happen, what is the combination of input bila kita nak reset kita punya latch. Okay, for to reset the latch, okay, we need to put SR sama dengan 0, 1. Okay, maksudnya kat sini, okay, you need to give an input lah. Input 0 letak ke S, R you give 1. Okay, from the same formula. Okay, so you kena dapatkan lah what is the output untuk Q and Q bar. So Q next sama dengan R tambah dengan Q bar current. Okay, and then barkan dia. So since R sama dengan 1, okay, you see R sama dengan 1, so you put 1 kat sini tambah dengan QC bar, and then you have a long bar kat sini. So 1 tambah dengan any value from your QC, tak kisah, regardless kamu akan dapat 1, and then you barkan dia. Okay, so your Q net will be 0. Okay, so that's why Q net is 0. So the expected output of kat sini is 1 lah, supposedly. Okay, which is 0 kat sini akan feedback masuk ke sini. Okay, so when sini 0, sini 0, you masukkan dalam the second persamaan, which is Q bar next sama dengan S tambah Q current bar. S kamu 0, Q current kamu also 0. So 0 tambah dengan 0, and then you bar, you will get 0 bar, which is equal to 1. So this one is 1. Okay, so what happened here? So when S, okay, bila SR sama dengan 0, 1, then Q next sama dengan 0, and Q next bar equal to 1. So this is how you reset ataupun clear the latch to 1. Okay, the R input stand for reset. So maksudnya kat sini, bila kamu letak R kamu sama dengan 1 means that you're going to reset. Okay, and bila kamu letak S kamu sama dengan 1 means that you're going to set. Okay, if you put R 0, S 0, both 0, 0, what happened here? You're going to store. Okay, so next, apa yang berlaku bila kamu letak S1 R1? So what happened when you put S1 R1? Okay, when both Q net and Q next bar will become 0, so this will control. Okay, so kita akan masukkan dulu kita punya persamaan, kita punya value. Okay, yang ni 1, yang ni 1. Okay, so kita dapatkan dulu dalam persamaan kita. So Q next sama dengan R tambah Q bar current, which is bar. R kamu sekarang ni 1 tambah dengan QC bar. So bar. So 1 tambah dengan QC, any value of your QC, okay, you will get back 1. And then 1 dia akan jadi 0. So this 0 here akan masuk ke sini. So what happen here? This is persamaan 1 and this is persamaan 2. From persamaan 2, Q bar next sama dengan S tambah Q current, and then bar. Since S is 1 tambah dengan 0. Okay, 1 tambah 0, you know that there is become 1. When 1 bar, kamu akan dapat 0, which is yang ni tadi 1, 0, and this is 0, which is not valid lah. Kenapa not valid? Supposedly, kalau sini 0, the Q bar should be 1. Tapi, in this case here, when Q 0, the Q bar also 0. Okay, so this one is wrong lah. Okay, so since this the both output of the latch given the same output value, okay, so this is the contradict the assumption that Q and Q bar are always complement. Okay, so in this case here, if you put SR sama dengan 1, 1, so this one here, this is or what we call here, we saying that this is a forbidden input. Okay, you cannot use the 1 1. Okay, you cannot set S1R1 for your SR latch because this is a forbidden. Kenapa forbidden? Sebab output kat sini Q and Q bar produce the same output. Dia tak complement each other. Okay, so this is a summarize lah. Okay, so this is the logic circuit for your active high SR latch, di mana okay, this active high SR latch is produced by using a cross couple NOR gate. Okay, and then this is the persamaan. Okay, this is the SR logic symbol. Okay, SR latch logic symbol. You has a input S, input R, output Q, and output Q bar. Okay, so this is the SR latch truth table. Okay, so kita hanya fokus pada this truth table je lah. Okay, bila S kosong, R kosong, Q next sama dengan Q. Okay, kita dah tengok tadi bila S kosong, R kosong. Okay, maksudnya kat sini you going to store your Q. Okay, dia akan store the Q value lah. Sama ada Q kosong, dia akan store kosong lah. If the Q is 1, and the value will remain 1. So action here is no change lah. The Q value not berubah. Okay, if you put S kosong, R1 means that you're going to reset. Okay, so that's why the output of your Q become kosong. And if you put S1, R0, so this one here, what happen is you're going to set. Okay, your latch, okay, which is your latch, the output of your latch become 1. If you put SR, S1, R1, so this is a forbidden. Kenapa forbidden? You see this output here, okay, always produce a 0 for both Q and Q bar, which is salah lah. Okay, so never set S1, R1 for SR active high latch. Okay, so this is for the active high SR latch. Okay, so kita akan buat what we call here. So this is the timing diagram of SR latch. So now you're going to find out what is the output of Q. Okay, so assume that Q ni tak ada dilukis lagi. So based on this input S and R, so you need to find out what is your Q and Q bar. Okay, so every time you see this kind of question, okay, selalunya untuk soalan latch and flip-flop, okay, you need to draw the timing diagram. So what you're going to do is, okay, mula-mula, okay, so this is your input. And this is your output. So apa yang kamu nak kena buat is, okay, kamu lukiskan dulu straight line of each of the edges of your input. Okay, setiap kali kamu tengok edge of your input, kamu lukislah kamu punya straight line. Okay, so lukis straight line, and this one have a straight line, another straight line, this is a straight line. Okay, so now we're going to find out what is our, kita nak lukis kita punya output Q and Q bar. So this is your Q and Q bar. So kamu nak lukiskan dia. Okay, so we know that tadi from truth table, when SR kosong, okay, so Q akan sama dengan Q, akan sama dengan Q, not Q bar ya, Q sama dengan Q. Okay, bila 01 means that you're going to reset, 10 you're going to reset, and when 11, so this is a forbidden. Okay, so kamu tengok ni, yang first kat sini dulu, this one ya. Okay, so this is a kosong kosong. So kosong kosong according to this one ya. Okay, let's the initial input of your queue yang ni lah. Okay. Mana saya punya ni? Okay, tak apa. Let's the initial of your queue is starting dekat kosong. Okay, since this is a kosong kosong. Okay, from here to here. Okay, daripada sini ke sini. Okay, kamu punya what we call here. Okay, so since this one is kosong kosong, from here is here, the value of Q is remain. Okay, so no change. Maksudnya dia akan follow the previous value. So that's why this one from here to here is kosong. Okay, and then from here, okay, saya lukis dekat ni lah, whiteboard lah, nampak sikit Sini tak nampak lah. Okay, let's, this is your SR latch. Okay, so let's, this is the timing diagram. This is your input S and this is your R, input R. Okay, so now you're going to find out what is your Q, timing diagram of your Q and Q bar. Okay, so this kind of question, macam saya katakan tadi, mula-mula, okay, so since this is your input, kamu draw dulu a straight line for every and edges. Okay, setiap kali kamu nampak je edge, kamu lukis straight line dulu. Okay, and then next, what you're going to do is you need to know lah your true table for the active high SR latch. Okay, so active high, this is the true table of active high SR latch. Okay, it's saying that when 00 Q tak berubah, 01 means that you're going to reset. 10, okay, Q akan jadi 1. When 11 yang ni tak, okay, yang ni nak, apa ni, we call it as a forbidden. Okay, which is the output here will be 00, always 00. Okay, untuk Q and Q bar. Okay, so supposedly Q and Q bar must complement each other lah. Okay, so let's, this one here, your initial Q starting from 1. Okay, so since this is 00, so 00, apa yang berlaku? 00, no change of your Q. Kalau kamu tengok pada what we call here, this truth table here, when you put S0, R0, there is a no change. So what happens here, from here to here, Q will follow the previous Q, which is 1. Okay, and then you have 1, 0. Okay, so 1, 0, what happens when 1, 0? So 1, 0 means that you are going to set your Q. So Q akan jadi 1 lah, because this is a set. And then when 1, 1, since this is a 1, 1, okay, so 1, 1, when 1, 1, what happens? This is a forbidden lah. Okay, so yang ni tak boleh. So by right, you need to put 0 lah kat sini. Sebabnya untuk forbidden, untuk 1, 1, the output of Q is 0 and Q bar is 0 as well. Okay, Q bar ni nanti later baru kita lukis. Okay, so this one you tulis dulu lah. This is a forbidden. Okay, you highlight that from here to here, this is a forbidden. Okay, then you have a 0, 1. So 0, 1, what happen for 0, 1? You're going to reset. Okay, so output kat sini akan jadi 0. Reset. And then this one here is 0, 0. So 0, 0. Apa 0, 0? 0, 0 means that you're going to store. Okay, Q no change. Q kamu tak berubah. Maksudnya you need to uh, follow the previous Q. What is the previous Q punya value? Kosong. So since the previous Q is kosong, so this one no change. Okay, and then this is 1, 0. When 1, 0, apa yang berlaku when 1, 0? This is a set. So kamu akan set. Kosong, kosong. No change. Okay, so dia akan jadi satu juga. Dia akan follow the previous Q. And when this one is 0, 1. So 0, 1, what is a 0, 1? 0, 1 means that you are going to reset. So this one become 0. Okay. Next, barulah kita lukis kita punya output. Sorry. Barulah kita pilih lukis kita punya output Q. So output Q akan, okay, by right, this output Q will apa ni, inverted of your input Q lah. Okay, so since this is a 1, so this is starting from kosong lah, kosong. Sorry. Okay, and then kosong. Kosong sampai sini kosong. Okay, you see here? Because this one daripada sini sampai sini is 1, so dia akan jadi kosong. But since this one is forbidden, so this is a remain kosong lah. Kenapa remain kosong? Because of this one ya. Okay, bila Q kosong for SR, bila S1, R1, your output Q is kosong, kosong. So this one is forbidden. Okay. So this region is a forbidden punya lah region. Okay, and then next, what happened here? So output Q kat sini from here to here is kosong, so you need to complement, so it will become 1. Okay, so since this one is 1, so dia akan complement become kosong, and since this is a kosong, dia akan jadi 1. So this is the output of your SR. Latch based on this timing, the timing diagram of SR, based on this input of SR. Okay, ada soalan tak untuk yang ini?
Doktor,
Ya, saya.
yang Q, yang first kita starting Q tu kan, so sebab kita punya SR kosong-kosong, tapi 1 tu sebab mungkin remain sebelum ni 1, so jadi 1.
Okay, ya betul.
Kalau dia sebelum ni value dia kosong, so maksudnya kita boleh still duduk line kosong lah.
Okay, contohlah. Okay, saya buat pula untuk condition bila dia punya starting dia, initial value kat sini kosong ya. Kita buat kat bawah ni. Okay, this one here, the starting point kat sini is kosong. So, apa yang akan berlaku? Okay, bila kosong, so this is a kosong ya. Dia punya initial value is starting from kosong. So, from here to here is kosong lah. Daripada bila S kosong, R kosong, dia akan follow previous value. The previous value is kosong, so dia akan remain no change lah. And then since this is 1 kosong, bila 1 kosong, dia akan set. So yang ni akan jadi 1. Okay, yang lain samalah, sama dengan yang atas ni. Okay, cuma kat sini je yang berubah. Kat kawasan ni je yang berubah. Sebab dia punya, because of this initial value. Tadi initial value 1, betul tak? Sekarang ni kita punya initial value is kosong. Q bar pun sama jugalah. Q bar akan berubah jugalah. Kat sini dia akan jadi starting from 1. Okay, and then this become kosong. And this is kosong lah sebab kat kawasan ni is forbidden. And the rest dia akan complemented.
Betul.
Ya, saya.
Initial value tu memang
Initial value akan diberi.
Oh, okay.
Okay, so initial value yang ni akan diberi. Jangan risau. Okay, kalau tak diberi nanti kamu angkat je tangan. Okay, nanti saya akan berikan dia punya initial value. Okay, this is untuk active high SR Latch. Okay, yang ni nanti kamu boleh tengok lah. Okay, dia sama je apa yang kita buat tadi. Okay, next we go to active low SR latch, which is S bar R bar latch. Okay, to get an active low SR latch, okay, which is S bar R bar latch, a NAND gate are used. Okay, kita gunakan NAND gate untuk dapatkan active low input S bar R bar latch. Okay, so this is the logic circuit and this is the logic symbol. Okay, since kamu tengok ni, so since the input of S and R ada bubble kat depan ni, so kamu tahulah this is a active low input S bar R bar latch. Okay, so just like an SR latch, but with the inverted input, as you can see from this table. So bila kosong kosong, okay, bila input S kosong, R kosong, so apa yang berlaku kat sini, dia jadi forbidden. Tadi bila satu-satu, forbidden. But now, untuk active low, bila kosong-kosong, it is a forbidden. Bila kosong satu, okay, means that you're going to set. Okay, bila kosong satu, you're going to set. Kenapa? Sebab yang ni, sebab dia ada S bar ni. Okay, bila S bar kamu letak kosong, so kamu tahulah, you are going to set. Bila R bar you put a 0, you're going to reset. Bila S bar, R bar is 1, 1, so this is no change. Okay, dia hanya inverted of sebelum ni. Active high SR latch. Okay, untuk latch ni, kamu hanya cuma perlu hafal dia punya truth table je. From truth table, once you hafal the truth table, then apa-apa soalan pun kamu boleh jawab. Okay, because kita hanya lukis dia punya timing diagram. Okay, so ada soalan tak untuk active low SR latch dengan active high SR latch? Okay, so contohlah kita buat example. Okay, untuk active low S bar R bar latch. Okay, so this is your okay, Q and this is your Q bar. Okay, so S bar R bar latch. Okay, so let's this is S bar R bar. Okay, so this is the input. Okay, so you need to find out what is your Q. Okay, lukiskan kamu punya Q and Q bar based on this input timing diagram. Okay, macam saya katakan tadi. Okay, dapatkan dulu. Okay, lukiskan dulu straight line setiap kali kamu nampak edges. Okay, and then obtain your truth table. Okay, so S bar, R bar. And this is your Q. Okay, bila kosong kosong, so this is forbidden. Okay, dia akan jadi 1, 1. So this is your Q bar. Okay, when kosong 1, so you're going to kosong is set. Okay, so this become 1. 1, kosong means that you're going to reset. And when 1, 1, there is no change. Okay, let's the initial value kat sini is kosong lah. Okay, so what happened here? Okay, so kita tengok kat sini. 0, 1. Okay, bila 0, 1, apa yang berlaku bila 0, 1? So you're going to set. Okay, so dia akan naik terus naik 1 sampai situ. Walaupun dia started with 0, so dia akan automatic naik sampai jadi 1. And then you have 0, 0 kat sini. So what is 0, 0? Apa yang berlaku bila 0, 0?
Forbidden.
Forbidden. Tapi dia punya output is 1 lah. Okay, based on this truth table, the output is 1. Okay, so kamu tulis dulu, this is a forbidden. So you know that Q bar kat sini nanti, kamu tak boleh complement lah. Kena ambil 1 ni nanti. Alright. And then this one here is 1, 0. What happen when 1, 0? 1, 0 kamu nak reset. Okay. 1, 1 tak berubah, which is follow the previous queue. Since previous queue is 0, dia akan ambil 0 lah. Value kamu tak berubah. Okay, and then 0, 1. Bila 0, 1 apa yang buat? Kamu nak set semula. Okay, and then 1, 1 no change. Okay, according to this one is no change. Follow previous queue. So which is jadi 1 lah. And then 1, 0 you're going to reset. And 1, 1 no change. So dia akan jadi macam ni. So next, lukislah kamu punya queue. Okay, so this is, since this is a 0, started with 0, kamu kena started dengan 1 lah. And then dia akan jadi 0. Okay, since this is a forbidden, so kena naik lah. Dia akan jadi 1. Okay, so this is a forbidden punya tempat. Okay, and then yang lain kamu kena complement. Okay, yang ni 1, so yang ni akan jadi, yang ni 0, output di sini 0, Q 0, so this is akan jadi 1. And see this region here, output is 1, so dia akan jadi 0 dan 1. Okay, so this is your timing diagram of output Q and Q bar for this S bar, R bar, active low latches. Okay, ada soalan up until here? Okay, kalau tak ada soalan, kita take 10 minutes break. Boleh tak? 10 minit. Kita sambung semula pada pukul 10 minit pagi.
Okay, sir.
Okay, next we're going to see the gated SR latch. Okay, so gated SR latch is a SR latch with a control input, which is kita panggil dia sebagai C ataupun sometimes EN, which is used to enable or disable your S and R input. Okay, so this is the what we call here, this is the logic circuit of gated SR latch. Kamu ada input S, kamu ada input R, and then this one here kamu sambung kepada C, and next this is kamu sambung kepada active low SR latches. Okay, so untuk gated SR latch, this gated SR latch diperbuat daripada NAND gates. Okay, notice that the dotted box is the S bar, R bar latch from the previous slide, and the additional NAND gates are simply used to generate the correct input for the SR, S bar, R bar latch. So ini dia punya logic symbol. Kamu ada 3 input, sebelum ni kamu ada 2 input, S, enable, R, and no bubble kat depan ni dah. Okay, Q and Q bar. Okay, so this control input is just act as okay, this control input act just like an enable. Okay, for this is a gated SR latch truth table. Okay, kalau control input is kosong, so regardless of your input S dengan R, okay, so the output will be no change. So output takkan berubah. Okay, bila mana control input your enable input is 1, then the output of your Q will change according to this SR input. Okay, bila 0, 0, no change, 0, 1, reset, 1, 0, you're going to set, and bila 1, 1, so this one here you need to avoid, which is a forbidden output. Okay, so let's look at the example here. Okay, now you're going to draw the output for the gated SR latch. Okay, so this is your enable input, and this is your SR or S input, and this is your R input. Okay, so first what you're going to do, apa yang kita kena buat is we need to know the what we call here, kita punya ni lah. okay, kita punya truth table of gated SR latch. Okay, so kamu ada enable kat depan ni. Bila kosong, okay, regardless of input SR, tak kisahlah S0 ke, R1 ke, Q sentiasa tidak berubah. Tapi bila enable kamu 1, so Q ni, the output of Q will depend on the input SR. Kalau 00 tak berubah, 01 reset, 10 set, 11 forbidden lah. Okay, so this one is forbidden. Okay, so this is Q bar. Okay, so let's look at this what you call it, timing diagram. Okay, given that your input enable S and R, next you're going to find out what is your output Q. Okay, and then dia bagi tahu kat sini the initial value of your Q is kosong lah kat sini. Okay, so first one you're going to do kat sini, alright, selalunya lah, okay, saya akan draw straight line every time I see the edges. Okay, so lukis dahulu straight line setiap kali kamu jumpa edge. Okay, so sekarang ni sebabnya kat sini kita ada enable. Okay, so we have an enable input. So what we're going to do is kita cari dulu yang enable kita sama dengan kosong. Sebab kita tahu bila enable sama dengan kosong, Q adalah Q bar. Okay, so this is enable, when enable sama dengan kosong, so Q akan follow the previous Q. Okay, so daripada sini ke sini, okay, because this is a depending on the enable, okay, because this one is 0, okay, daripada sini ke sini is kosong. So what happen to our Q? Q akan jadi kosong sampai situ. Okay, next barulah bila enable kita 1, baru kita fokus pada kita punya input S dengan R. So this one is S1, R0. So apa yang berlaku? Kamu nak setkan dia. And 00, since this is a 00, Q kamu tidak berubah. Follow previous Q. Okay. Okay, next. The next cycle is, kamu tengok kat sini. Di sini enable kamu 0. So, apa yang akan berlaku bila 0? So, tak perlu tengok kamu punya. Okay, you no need to see the input S dengan R. Sebab regardless of input S dengan R, Q, your output Q always Q, which is follow the previous Q lah. So, kita akan follow previous Q, which is previous Q is 1. So, kita akan follow sampai sini 1. Okay, and then when enable is 1, so barulah kita tengok kita punya S dengan R input. So, this is 00. So, this is output akan jadi 1. And then when 1, 0, this is remain 1. Okay. And then this one yes, masih lagi 0, which is tak perlulah tengok kamu punya input S dengan R. So, follow previous Q. And since this one is enable is 1, so baru kita tengok kita punya SR. So since this one SR is 01, so now you going to reset sampailah kat situ. And this is another enable 0, so dia akan follow previous Q. So this is the answers. Okay, so any question for the gated SR latch? Okay, for the gated SR latch, kita kena tengok, okay, kena ni lah, kena take the, okay, you need to consider the enable value as well. Okay, because the enable become your inputs. Okay, next is a gated D latch. Okay, tadi kita dah tengok gated SR. Next, we are going to see the gated D latch. Okay, so gated D latch is based on the S bar R bar latch. The addition gate generate the S bar R bar signal based on input D data and C control. Okay, so with a few modification, okay, bila kamu tambah aja few modification kat sini, okay, di mana previously, okay, kalau previously kamu tengok kat sini, okay, kamu ada S dengan R input. So now, what happen is, you combine this input S and R, make it as a D. So kamu akan dapat gated D latch. Okay, so nampak ni, this is your D. Okay, so this D, the first D go to the first NAND gate. The second D masuk kepada NOT gate and then go to the second NAND gate. So this is your get apa ni tadi? Active low S bar R bar latch. Okay, so for this one, okay, for the gated D latch, okay, so this is the what we call here the truth table that you need to remember. Bila control kamu ataupun enable kamu sama dengan kosong, regardless of your D, tak kisahlah D kamu ke 1 ke kosong, the output will be no change. Okay, if the control is 1, then the output of Q will depend on D. Okay, if D kosong, Q next is kosong, D1, Q next is 1. Okay, so again, okay, also this latch has no bad input combination to avoid. Okay, tak sama dengan gated SR latch di mana bila kamu letak satu-satu, the output will be forbidden. Untuk D latch, there is no forbidden input. Okay, kenapa? Sebab dia hanya ada 2 input aja. Okay, dia hanya ada combination of sama ada kosong ataupun 1. And then both of this input here will produce value. Okay, so this is for the D gated D latch. Okay, so draw the output of Q based on the gated D latch. Okay, sama jugalah tadi. Draw dulu straight line. Untuk setiap edges kat sini. Okay, bucu kat sini kamu draw dulu straight line. Okay, and then you need to remember the truth table lah. Okay, so this is your enable and this is your D and this is your output Q. Kalau enable kosong, regardless of D input, the Q no change. Kalau yang ni satu-satu, the output of Q will depend on your D input. If D is kosong, the output will be kosong. If D is 1, the output will be 1. Okay, so now we're going to lukis the output. Okay, the timing diagram of the output Q. Okay, since this one here enable kosong. Okay, so initial value is kosong. So started from here to here. Okay, Q. Okay, there is no change. So follow the previous Q. Okay, so now enable sama dengan 1. So you need to see your input D lah. Okay, if D kosong, so dia akan jadi kosong. If D is 1, so it will become 1. Okay, and then from here to here, enable is kosong. So when enable is kosong, what happen is you follow the previous Q. Our Q previous Q is 1, so no change kat sini, so dia akan jadi 1. And when enable is 1, so what happen? You need to see the input D lah. Okay, so started from here, D is kosong, so dia akan jadi kosong. And D is a D kas 1, dia akan jadi 1. And kosong, and it will become 1 kat sini. Okay, and then what happened here? D is a kosong. So from here to here means that the output of Q no change. So dia akan jadi 1. So this is the lukisan lah of the timing diagram output for the output Q of D gated D latch. Okay, so any question for the gated D latch? Ada soalan tak? Kalau tak ada soalan, next we go to the gated JK latch. Okay, for the gated JK latch is another way to improve the gated SR latch. Okay, so the input of J and K perform exactly the same as S and R with the exception of the condition of JK sama dengan 1, 1. Di mana previously, when S and R is 1, 1, so you will produce a forbidden output. But for the JK, if you put JK equal to 1, 1, okay, the output will tonggers. Okay, no more forbidden output. Okay, so this is the gated JK latch logic circuit. Okay, di mana sama juga dia guna 4 NAND gates. Okay, tapi with a few modification lah. Okay, tadi kamu previously kalau kamu tengok gated SR, dia cuma macam ni je. Okay, tadi gated SR kamu ada macam ni. Press enable R and then okay, yang ni tadi gated SR. Tapi untuk gated JK, you need to do some modification lah. Okay, so what happen here is, okay, yang ni kamu sambung kepada J, yang ni kamu sambung kepada K, and then tambah lagi kat sini. This one here akan sambung kepada sini, and yang ni sambung kepada output Q. So kamu dah jadikan dia sebagai gated JK. Okay, with minor modification of the gated SR, kamu dah jadikan dia sebagai gated JK. Okay, so this is the symbol of the gated JK. Okay, kamu ada input J, enable, and K as an input. Output is Q and Q bar. And this is the truth table of gated JK latch. Okay, bila enable is kosong, sama jugalah. Regardless of your JK input, the Q will not change. Bila enable is 1, then the output of Q will depending on the inputs of your JK. Okay, if kosong kosong, Q not your Q is no change. Kosong 1, you're going to reset. 1 0 is set. 1 1, what happened to your Q? Q akan jadi toggle. Okay, so there's something like this lah, macam yang ni. Okay, so we draw a straight line. Okay, so this is your enable. Kamu lukislah straight line untuk enable. Okay, since this is enable, so initial value of Q is kosong. So since this is a kosong, so starting from here to here, it will produce kosong lah. Okay, because this is a no change. And when enable is 1, okay, daripada sini enable is 1, so you need to see what is the input of your JK. Okay, since this is 1 kosong. Okay, when 1 kosong, what means is you going to set lah. Okay, yang di tadi, J tadi kan kita sambung kepada S. Yang K tadi is coming from your R. So, when J1, so you going to set. And this one here, when 0, 0, what happen when 0, 0? Apa berlaku bila 0, 0? 0, 0 maksudnya no change. Okay, so sepatutnya kat sini 1. Okay, bukan kosong ya. Because when 0, 0, this one is no change. Tak berubah.
So graf tu salah ke doktor?
Sekejap ya. Saya dah okay, 1, 0 is set. Okay. Bila 0, 0, okay, ya graf ni sini salah. Okay. So bila 0, 0, so no change sampai sini. Okay, saya draw dulu dia punya lines dia. Okay. So no change. Vale. Okay, so kosong kosong. Mana saya punya ni? Tak keluar pula saya punya ink. Okay, so kosong, this is kosong kosong. So kamu punya tak berubah ya. Q kamu tak berubah, follow previous Q, which is previous Q is 1. And then this one here is 0, 1. Okay, what happen when 0, 1? Apa yang berlaku? Kamu nak reset, barulah dia jadi kosong. And then kosong kosong tak berubah. Okay, and then when this one is kosong 1, okay, you going to reset again. Okay, bila kosong 1, you're going to reset again. So dia akan kosong. And bila mana this one is 1, 1. Okay, what happen bila 1, 1? Dia akan jadi toggle. Maksudnya Q sekarang ni is kosong, dia akan jadi 1. Dia bukan jadi macam bentuk ni ya. Which is this one is wrong. Yang ni salah ni. Yang ni salah. Okay, dia tak akan jadi macam ni. Dia hanya akan toggle je the previous Q. Okay, kita buat lagi satu contoh lah. Kita buat contoh. Contoh lain.
Toggle tu means the opposite of the previous action tu lah.
Ya, betul.
Previous.
Ya, maksudnya kita complement the previous output. Okay, so kita do another contoh lah kat sini. Okay, you have a JK enable Q and this is a Q bar. Okay, this is your enable input. And this is your J and this is your K. Okay, and then K is something like this. Okay, then you need to find out what is the Q and Q bar punya outputs. Okay, lukiskan Q and Q bar based on this timing diagram. Okay, so mula-mula kita tandakan dulu kita punya enable. So this is your enable. Okay, and then after that, okay, you know that when enable is kosong, okay, tak perlu tengok pun kamu punya input JK. Okay, so just ignore your input JK. Okay, let's your Q is started with 1. Okay, the initial value of Q is 1. Okay, and then this one here, when enable is 1, then you need to see your JK input lah. Okay, kena tengok JK punya input. So draw a straight line here. Okay, and then dapatkan truth table. So this is your JK punya truth table. Kosong, regardless of this value, okay, Q will not change. When 1, kosong kosong, apa yang berlaku bila kosong kosong? Q follow the previous Q, no change. Kosong 1, what happen when kosong 1? Okay, you're going to reset with this kosong 1 kosong, you're going to set, and when 1 1, so you're going to, okay, the Q will toggle. Okay, so now we lukis dia punya output. Okay, since this is the initial value is 1 and enable started from here to here is kosong, so maksudnya Q takkan berubah, which is no change. Okay, follow previous Q. So dia akan jadi 1 lah sampai kat situ. Okay, and next since this one here, enable adalah 1. So bila mana enable adalah 1, so you need to see the input JK to find out the output Q. Okay, so yang ni started from with this one, this is 01. What is 01?
Reset.
Okay, kamu nak reset, so dia akan jadi 0 lah sampai situ. And then this is 00. 00 tak berubah, no change. 10 10, apa yang berlaku bila 10? You're going to set 11. What happen bila 11? Okay, dia akan jadi toggle. Okay, so sekarang ni Q is 1, so dia akan jadi automatic jadi 0 lah. Okay, bila 00 tak berubah, follow previous Q. And this one here is 11. What happen bila 11? Dia akan toggle sekali lagi. Okay, daripada 0 jadi 1. And then this is 01. What is 01? What is the expected output of 01? Apakah clear or reset? Okay, and then this one is 00. No change. 10. Okay, set. 00. Okay, no change. 01.
Reset.
Reset. 11.
Toggle.
Okay, toggle. And then bila enable 0, regardless of your input kat sini, dia akan
No change.
no change. Okay, so this is the output of your Q. Okay, what about Q bar? Bila Q bar kamu complement je lah output Q ni. So since this is ke 1, so dia akan started with 0. And yang ni akan jadi 1. 0. 1. Okay, inverted je kamu punya Q tadi. Okay, so this is the output of your gated JK for both Q and Q bar. Okay, ada soalan tak?
Doktor,
Yes, saya.
usually questions untuk latches ni dalam test atau exam, soalan dia akan tanya output macam ni je ke atau lagi complicated?
Dia akan tanya complicated lah. Mungkin dia akan tambah gates kat sini nanti. So nanti kita akan ada a few examples or the previous punya final exam, previous test untuk kita buat. Okay. So tak ada lah dia bagi, okay, satu gate JK ni find out what is the output of Q. Tak macam tu. Dia akan tambah a few ni lah, bagi payah sikit lah. Tak more straightforward. Okay, any other question? Ada soalan lain tak? Sebelum kita nak masuk kepada flip-flop.
Doktor, saya nak tanya satu.
Yeah.
Yang untuk Q bar tu kan, yang untuk bila kita case 1-1, dia jadi dia output forbidden kan?
Betul.
So macam tadi yang macam true table forbidden tu, dia output dia jadi 0-0, Q dan Q bar 0-0.
Ya, betul.
Tapi kalau dekat kita punya value ni pun dia, kalau dia 1, maksudnya yang satu lagi akan jadi 1 juga ke, ataupun dia akan terbalik?
Okay, untuk case yang JK, okay, JK Latch, kita dah tak ada forbidden punya output. Okay, forbidden punya output no more. Maksudnya sini, bila Q kita kat sini 0, okay, ini untuk case 1-1 Q bar akan jadi 1. Okay, sini. Okay, this is your Q bar. Okay, yang ni akan jadi Q bar. This is a Q bar, this is 1, this is 0. And this is become Q lah. Okay, bila 0, dia akan jadi 1. Bila 1, dia akan jadi 0. Dah tak ada dah lagi forbidden punya input.
Oh, jadi maksudnya kalau untuk latch yang lain kita mesti guna yang 0-0 tu lah
Ya, betul. Untuk yang latch SR, bila satu-satu Q bar dia punya output masih lagi kosong-kosong. Di latch tak ada Di latch pun tak ada forbidden inputs. Untuk SR saja.
Okey, Doktor. Okey. Terima kasih.
Okey, sama. Okey, kalau tak ada soalan, next kita pergi masuk pada flip-flop. Okay, so this is the overview of flip-flop. Okay, flip-flop are synchronous bistable device. Mana saya punya pointer? Okay, the term synchronous means that, okay, dia kat sini dah ada synchronous, that the output change state only at the specific point on the triggering input called the clock. Okay, the difference between latch dengan clock, latch tak ada clock tapi flip-flop ada clock input. Okay, so this clock is designated as a control input, which is dalam latch kita ada enable, tapi dalam flip-flop kita ganti dengan clock. That is change in the output occur in synchronization with the clock. There are three types of flip-flop: D flip-flop, JK flip-flop, and T flip-flop. Okay, so sebelum kita go more detail on the flip-flop, okay, the three flip-flop, JK, D flip-flop, and T flip-flop, first we need to know lah what is the edge triggered. Okay, so an edge triggered flip-flop change state either at the positive edge, which is a rising edge, or negative edge, which is a falling edge of the clock path. Okay, so it is sensitive to its input only at this transition of the clock. Okay, so the output hanya berubah sama ada kamu bila mana your clock is rising edge ataupun falling edge. Other than that, output kamu akan the output of the flip-flop will follow the previous Q, which is no change to the outputs. Clock input of flip-flop are symbolized by a triangle in a logic symbol. So every time you see the triangle kat sini, okay, dekat kamu punya logic symbols, so you know that one is belong to flip-flop lah. Okay, contoh, saya bagi contoh. Okay, what is the difference between nombor 1, logic symbol nombor 1 and logic symbol nombor 2?
Dia punya clock.
Okay, so logic symbol nombor 1, okay,
Latch.
so this one here kita panggil dia sebagai JK
Latch.
latch. Okay, logic symbol nombor 2, kamu nampak ni ada triangle.
Flip-flop.
So this one here become
JK flip-flop.
okay, it is for the flip-flop. Okay, JK flip-flop. Okay, that is the difference. Satu tak ada triangle, satu lagi ada triangle. Okay, so now you can differentiate lah between mana satu latch, mana satu flip-flop. Okay, for the positive edge trigger device, okay, maksudnya dia akan berubah bila rising edge. Apa rising edge? Whenever you punya clock is change from 0 to 1. So this is a rising edge. Macam mana nak tahu this is a rising edge? Okay, kat depan ni tak ada bubble. Okay, there is no bubble in front of this flip-flop. Okay, in this clock source. While for the negative edge triggered, you see there is a bubble kat depan ni. So you know that one is belong to negative edge triggered, which is the output of your Q kat sini berubah bila mana the clock source, okay, change from high to low, which is falling edge daripada 1 to 0. Okay, so the positive edge triggered no bubble at the clock input, while the negative edge triggered has bubble at the clock input. Okay, now you're going to see the flip-flop. Okay, the D flip-flop. Sebab kamu dah tahu dah positive edge triggered macam mana, negative edge triggered macam mana. So now we're going to see the D flip-flop. Okay, so D flip-flop is useful when a single data bit 1 or 0 is to be stored. Okay, so D flip-flop ni kalau kamu nak store 1 or 0, kamu boleh guna D flip-flop. It has 2 input, which is clock input and D input, and 2 output of Q and Q bar. Okay, it work almost the same as the D latch. Okay, dia punya function sama dengan D latch. Ada 1 input D, ada 1 clock input, 2 output, which is Q and Q bar. Okay, when a clock pulse arrive, the input is transferred to the output. Okay, the D flip-flop can be either positive edge or negative edge triggered. So in this case here, D is a positive edge triggered. Kenapa positive edge? Because there is no bubble in front of the clock source. Okay, for the positive edge triggered D flip-flop, the input only valid or seen during the clock rising edge. Okay, contoh, this is the truth table, okay, ataupun characteristic table of the D flip-flop. Okay, bila clock kamu kosong, regardless of your D, sama ada D kamu 1 ke D kamu kosong, the output of Q no change. Okay, if your clock is 1, regardless lah dia input D kamu sama ada 1 atau kosong, Q no change. Okay, but if your if pada masa tu this one is a rising edge, your clock is a rising edge, okay, which is change from 0 to 1. Okay, dia berubah daripada 0 kepada 1. Okay, so kamu kena tengok kamu punya D. Okay, at this moment here, pada waktu ni, at this very moment, you need to refer to your D. If your D is 0, then the output will be 0. If your D is 1, then the output will be 1. Okay, so let's look at this example here. Okay, saya lukis yang ni tak berapa cantik, saya lukis dekat whiteboard. Okay, kamu ada, this is your flip-flop. Okay, so this one you sambung kepada C and D, and this one you sambung kepada clock. And this is your Q and Q bar. Okay, so let this is your clock source. Okay, so this is your clock, and this is your input D. Okay, now you're going to find out what is your Q. Okay, so according to this timing diagram, you need to draw, okay, find out what is your output Q. So mula-mula, kita kena refer dulu kita punya lukisan. Okay, since this lukisan here, okay, you using a positive edge triggered. Kenapa positive edge triggered? Because no bubble in front of this flip-flop. So for the positive edge triggered, so it is a rising edge lah. So rising edge, okay, kamu lukis dulu rising edge, okay, identify kat mana dia punya rising edge from your clock's input. Okay, so this is your rising edge. So once you dah lukis dia punya rising edge, then you draw a straight line. Okay, yang ni kita draw straight line dekat clock sahaja, clock input sahaja. Okay, and then once you finish, and then after that barulah kita dapatkan kita punya Q. Okay, let's this Q here started initial value of Q is 1 lah. Okay, so from here to first rising edge, okay, so yang ni saya letak nombor 1, this is the first clock cycle, second clock, third, fourth, fifth and sixth clock cycles. Okay, for the first clock cycle, okay, started from here until you reach the first clock cycle, so the output of Q no change, which is follow the previous Q lah, which is 1. Okay, and then bila kat sini, okay, bila the first rising edge, what happen is you need to see what is your input D. Okay, so at this moment, okay, so you know that this is the truth table of your D flip-flop. Kamu tahu, bila D kosong, output kosong, D1, output 1. Okay, so since this one here, the input D of is 0, so what happen? So automatically, okay, Q jadi kosong. Daripada sini sampailah the next rising edge. Okay, so you just look it from here until the next rising edge. Okay, so anything in between here tak tengok. Sebabnya dia hanya berubah bila rising edge. Okay, every rising edge. Okay, setiap kali rising edge baru dia berubah. Okay, the output of Q will change. Okay, so next, bila second clock cycle, which is the second rising edge, so next you're going to see what is your input D. So since this one is 1, so what happen? So dia akan berubah daripada kosong kepada 1, and then sampai bila? Sampailah the next rising edge. Okay, you look at sampai the next rising edge. Okay, when here dekat cycle number 3, so once D is kosong, so you jadikan dia kosong, rising edge. Okay, so since this one here, the D is 0 as masih lagi kosong, so kamu lukislah kosong sampai the next rising edge. Okay, in the fifth cycle, okay, the fifth rising edge, what happen is the D is 1, so kamu lukis dia sama dengan 1 sampai next rising edge. Since this one is 0, so dia akan jadi kosong. Okay, boleh. Okay, untuk Q bar, so Q bar kamu inverted lah the output Q ni. So contoh, this is a Q bar. So apa yang berlaku? Kosong, 1, kosong, 1, kosong and 1. So this is your output Q bar. This is for the rising edge. Let's say lah, okay, now, okay, the same input D, so now I sambung kepada negative edge trigger. So I need to find out what is my output Z, for example. So this is Z and this is a Z bar. Okay, so this is my Z. So untuk yang second punya example ni, so what I need to do is, so since this one here, this is a negative edge trigger, so kena lukis lah every falling edge, then I need to draw a straight line. Okay, so since, okay, so this is a straight line, I draw the straight line for every falling edge. And then after that, barulah lukis kamu punya, okay, dapatkan output Z according to this clock and D inputs. Okay, let's kamu punya Z started with the initial value of Z is kosong lah. Okay, so kosong. So apa nak buat? So this kosong here until the first falling edge, you lukis lah dia sama dengan kosong. And at the moment dia okay, you the clock is on the falling edge, so you need to see the inputs. Okay, since this one is 1, so dia akan jadi 1 sampailah next falling edge. Okay, at the moment here, okay, for the second falling edge, the inputs remain 1, so dia akan jadi, the output will be 1 until the next rising edge, which is dekat sini, the third sorry, not rising edge, the falling edge. Okay, for the third falling edge, the input is 0, so now it become 0 until the next falling edge. Okay, the next falling edge here, the input is 1, so dia akan jadi 1 sampai next falling edge. And at this moment here, the input remains 1. Okay, so dia akan jadi remain 1 sampai the next falling edge. Okay, kat sini dia akan jadi kosong. Okay, so this is the difference lah between the positive edge trigger and negative edge trigger for D flip-flops. Okay, ada soalan tak? Okay, next we'll look at another examples. Okay, kita tengok example yang lain. Okay, so this one here, okay, you have a D versus D latch versus D flip-flop. Okay, saya ambil benda yang sama lah, yang lukisan yang sama yang tadi. Okay, next, from the same input here, okay, next I sambung kepada D latch. Okay, so this is my D latch. So see what happened. Okay, SKEU Q bar. Okay, so this one saya jadikan dia sebagai Y lah, output Y, sambung kepada Y. So this Y bar. Okay, so now I need to find out what is my Y. Okay, so cari apakah saya punya output Y. Lukis my output Y. Okay, so since this one here, okay, no, apa ni, kita panggil triangle. Okay, at the clock source, so kamu tahu this is belong to the latch. Okay, because tak ada triangle kat situ. Okay, for the D latch, so apa yang kamu kena buat is, okay, since this is this clock here become your enable, so you need to see the enable lah. Okay, so lukiskan dulu kamu punya ni straight line kat sini. Okay, so this is your straight line for each of this enable kat sini. Okay, saya tarik lebih panjang. Okay, so let's this one here started with kosong. Okay, the initial value is kosong jugalah. Okay, so baru kita tengok. Okay, so this is your enable. Okay, so this is your enable. Your clock now become enable, and this is your input D. Okay, so bila clock kamu kosong, so what happen when clock kosong? Untuk latch, kita tak tengok dia punya rising edge or falling edge, kita tengok dia punya level trigger, sama ada dia kosong ke 1. Kalau kosong, what happen? Untuk D latch, siapa nak tolong?
Follow,
No change.
no change.
Okay, no change. Okay, follow the previous queue. Bila enable sama dengan 1, barulah kamu tengok kamu punya input D. Bila input kosong, dia akan kosong. Bila input 1, dia akan jadi 1. Okay, since this is a kosong, so no change lah. Started from here sampai kat sini. Okay, since this is 1, okay, bila this is 1, so you need to follow the D lah. Input D. Okay, so input D ni nampak ni. Okay, started from here to here, dia kosong. So sini sampai sini dia kosong. And then suddenly dia jadi 1. Okay, kat sini dia jadi 1. Okay, and then kat sini dia is kosong, so no change lah. This one no change. Okay, and then dekat sini dia is a 1. Bila 1, you need to see the input D. Since from here to here your input D is 1, so you just lukis 1 je lah. Okay, so D is kosong, another kosong, no change. Right, so here D is 1, so 1 kamu tengoklah input D is 0, so dia akan jadi kosong. Okay, kosong, this is a no change. And since this is a 1, okay, so you need to see your input T. So this is your input D lah. Okay, so daripada sini sampai sini kosong and then suddenly it become 1. Okay, so this is a kosong, no change. And bila 1, you need to see your D. So since your D is always 1, so you lukis lah always 1 sampai situ. And this one is kosong, so no change. And this is a 1, so you need to see your D. The input D is 0, so it will become 0. And D is kosong, so another no change. So this is the output of your D latch. Okay, so this is the D latch, and this is the D flip-flop with negative triggered. And this is the output for D flip-flop with positive edge triggered. Okay, so the output will be different lah. Okay, according to the input and clock input source. Okay, so ini nanti kamu boleh cubalah dekat rumah nanti. Saya tak pasti sama ada jawapan dia betul ke tak. Okay, kalau salah nanti kamu betulkan lah dia punya jawapan. Okay, next we have a T flip-flop. Okay, T stand for toggle that has 2 input, okay, which is a clock input and T input. Okay, so this is your toggle. Okay, so this is your T flip-flop. This is the logic symbol of T flip-flop. Kamu ada T input and clock input and 2 output of Q and Q bar. Okay, for the T flip-flop, okay, whenever your T equal to 0, Q will no change. Okay, bila T sama dengan 1, Q akan toggle. Okay, Q akan berubah. Okay, bila ni every rising edge, because this is a positive edge trigger. So every rising edge, bila T sama 0, Q tak berubah. Bila T sama dengan 1, Q sama dengan toggle. So tolong tukar yang ni. This action here is wrong ni. Okay, so this one is no change and this is a toggle. Okay, if the other than that, okay, if the clock input is either 0 or 1, regardless of your T input, the output will no change. Okay, so let's look at another example. Saya lukis kat sini. Okay, so this is your T flip-flop. Okay, kamu ada 2 T flip-flop kat sini. Okay, this one here akan sambung kepada input, the same input, which is kita panggil dia sebagai T. And then this clock here will sambung kepada same clocks, okay, which is denoted as a CLK. And this is your Q, Q bar. And T is become, okay, P. Okay, so this is your clock input. Okay, and then this is your T inputs. Okay, then you need to find out what is the output Q and P. Okay, let's the initial value for both here is 0. So macam mana nak buat? what you going to do? Okay, so mula-mula kita kena identify lah. Okay, so you have a T flip-flop. Okay, both circuit you have T flip-flop. Okay, the first T flip-flop here is a positive edge. Okay, so this is a positive edge. So you know that this is a positive edge. And the second one is negative edge. Kenapa negative edge? Because the clock source here coming from, you have bubbles. So this is a negative edge triggered. Okay, for positive edge, kita akan tengok every rising edge of your clock source. Okay, your output T, okay, your output Q hanya akan berubah every rising edge. Okay, setiap kali dia rising edge, dia akan berubah. Okay, and then dapatkan dulu dia punya truth table of T flip-flop. Okay, T, Q. Bila T kosong, what happened to your Q? What is your output Q? When T kosong. Anyone? Siapa nak tolong?
1. No change.
No change.
Okay, no change ya. So this is no change. When T1,
No change.
dia akan toggle. Okay, ingat ni, kena memorize ni, dia punya truth table ni. Okay, kalau D, kosong satu, bila kosong is kosong lah. Bila satu dia akan jadi satu. JK flip-flop pun kamu kena ingat juga dia punya truth table nanti. Barulah kamu boleh jawab soalan dia nanti. Okay, so kita find out kita lukis dia punya output dulu. Okay, so since this initial value is 0, so starting from here until, okay, saya 1, 2, 3, 4, 5. Okay, started from here to first rising edge, dia akan kosong lah. Okay, no change here, which is follow the previous Q. Kosong. And then, at the first rising edge, what you going to do? Tengok yang ni. Okay, tengok the T value. Since this T here is kosong, so what happened to your Q? Q akan toggle ke ataupun no change?
No change.
Okay, no change. So Q akan remain 0 until the next rising edge. Okay, for the second rising edge, okay, then you see the T. Okay, now the T input is 1. So what happened? Bila T input is 1?
Toggle.
Okay, dia akan toggle lah. So dia daripada kosong, dia akan jadi 1 until the next rising edge. Okay, at the next rising edge, you tengok you punya T is 0. So what happened when T 0?
No change.
No change. Okay, remain 1. And this one here, T is 1.
Toggle.
Toggle. Okay, so dia akan jadi kosong. And this one here, T is 0, so no change. Okay, so this is the output of your first flip-flop. Okay, the positive edge triggered. Okay, next you're going to draw the second, the output for the second T flip-flop. Okay, since this one here is negative edge triggered, so the output of flip-flop, second flip-flop will only change every falling edge. Okay, so you draw a straight line every falling edge. Okay, so initial value is 0, so started from here to here, dia akan remain 0 lah. Okay, next, you see this is 1. The first falling edge is 1. So what happen? Bila 1, dia akan toggle. Okay, and this one here is 0, so remains no change. This one still 0, no change until next falling edge. Okay, and toggle. Okay, this one is 1, so dia akan jadi toggle. And kat sini dia kosong. So what happen when kosong? No change. Okay, so dia remain kosong. This is the output lah untuk your second punya flip-flop. Okay, so next. Okay, so yang ni kamu boleh try lah nanti ya. Hopefully the jawapan is correct lah. Okay, next is the last flip-flop is JK flip-flop. Okay, so JK flip-flop is a versatile and is widely used type of flip-flop. Kenapa JK flip-flop is versatile? Because you can, by using the JK flip-flop, you can use it as a D flip-flop. By using the JK flip-flop, you can use it as a T flip-flop. Okay? Dengan satu flip-flop ni, kamu boleh jadikan dia sebagai JK flip-flop. Pada masa yang sama, kamu boleh jadikan dia sebagai D flip-flop, tapi kena buat modification lah. Okay, with a minor modification. And pada masa yang sama, kamu boleh jadikan dia sebagai T flip-flop. Okay, so this JK flip-flop is identical to JK latch, where the output is toggle or inverted when JK equal to 1, 1. Okay, yang bezanya, the input is changed during a clock age. Okay, so the output akan berubah bila mana setiap kali dia punya clock age, either is a positive age trigger or negative age trigger. So this is the characteristic table for JK flip-flop. Okay, if the clock source is either 0 or 1, so regardless of your JK, the Q will not change. Okay, and untuk case yang ni, since this is a positive age trigger, every rising age, so the output of Q will change according to your JK input. If 0, 0, the output is no change. 0, 1, reset. 1, 0, you're going to set. 1, 1, you're going to toggle. Okay, so let's look at this contoh kat sini. So saya lukis yang ni tadi. Mana kita punya JK tadi . Okay, where is our JK just now? SR. Okay, so this is JK latch. Okay, tadi kita buat JK latch, betul tak? So now we have a JK flip-flop. Okay, so you have this one. JK, and then you have this one. And this Q and Q bar. Okay, let's this one connect to J, and this connect to K, and this one connect to your clock source. And this is your Q, and this is your Q bar. Okay, so this is your clock source. The timing diagram of your clock source. And this is your J inputs. And this is your K inputs. And you need to find out what is your output Q. Okay, so in this case okay, first what you're going to do is kita identify lah kita punya JK flip-flops. Okay, so since this one no bubble, so you know that it's a positive age triggered JK flip-flop. So dia akan berubah every rising age. So setiap kali rising age, you draw the line. Okay, so this is the lines. Okay, you have 5 cycles. Ada 5, 3, 4, 5. Okay, so 5 cycles of your clock source. And then, lepas tu nak buat apa? Sebelum kamu lukis. Okay, let's this one here, assume that this one started with 1. Okay, before kamu lukis, nak buat apa dulu? Dapatkan dulu kamu punya truth table of your JK flip-flop. Okay, bila 0, 0, what happen bila 0, 0? What is the output of Q?
No change.
No change. 0, 1. Reset. 1, 0. Set. 1, 1. Toggle. Okay, so started from here. 1 to the first rising age. Apa berlaku? No change ya. Dia tak berubah. Okay, and then bila this first rising age, then you need to see the JK input. Okay, so this JK input here, what is the value of your JK kat sini? 0,
0, 1.
1. 0, 1. Okay, so 0, 1, you know that you're going to reset. Okay, so reset from here until next rising edge. Okay, when the next rising edge, then you see the input. The input now change from, okay, 1, 0. So 1, 0, what happen when 1, 0? You're going to set. So dia akan set daripada sini sampai next rising edge. Okay, at the next rising edge, you see here the input is 1, 1. So since this is a 1, 1, so what happen? Dia akan toggle. Okay, bila 1, 1 toggle, so dia akan jadi. Okay, since this the input is 1, so bila toggle, dia akan jadi kosong. Okay, next, sampailah next rising edge. When the next rising edge, the input is of JK is 01. What is 01? 0. Okay, you're going to reset. And then after that, you see here until the next rising edge, you see here this one here is 1, 1. So another toggle until the next rising edge. So this is the output lah of this JK flip-flops. Okay. So, okay, so we have seen 3 types of flip-flop previously. Okay, this flip-flop can be implemented by using the JK flip-flop. Okay, so to implement a D flip-flop by using a JK flip-flop, so you just put the inverter dekat sini, dekat K, and connect the both J, K to the same clock source. Okay, tadi kita punya JK macam ni. Okay, so this is your JK flip-flop. Okay, how this JK flip-flop to be implemented as a D flip-flop? Okay, to implement this JK flip-flop sebagai D flip-flop, what you going to do is, sebab kita tahu untuk D flip-flop, okay, for D flip-flop, kita hanya ada satu je input, which is D. And that's, of course lah, kita ada another input called clock source. Okay, so untuk the input is satu je D. Okay, so this is the truth table. 0, 1. So what happen here is, apa yang kamu kena buat? Okay, since this JK flip-flop, you have 2 input, which is J and K. So you need to combine lah this JK supaya dia jadi 1. So what you going to do is, you need to sambung ni kepada D. The J go to the D, while this one here sambung ke NOT gate and then masuk kepada K. Okay, clock ni go to your clock and this is your Q and Q bar. So now you have the D flip-flop. Betul tak? This one is D flip-flop. Masukkanlah dalam persamaan. Okay, masukkan dalam circuit. So when D is a kosong. Okay, so J akan jadi kosong. K akan jadi 1. So bila kosong 1, what is your output Q? Bila kosong 1.
Reset.
Okay, bila kosong 1, Q sama dengan kosong. Betul tak? Bila D kosong, Q sama dengan kosong. Okay, next kamu masukkan pula 1. 1. Okay, J akan jadi 1. Okay, K akan jadi kosong. Bila J1, K kosong, what happen to your Q? J1, K kosong, dia akan jadi set. Okay, dia akan jadi set. So this one pun sama lah. Okay, so now dah jadi. Okay, you already designed the D flip-flop by using the JK flip-flop. Okay, so macam mana pula kita nak buat? Nak guna JK flip-flop tapi nak implement T flip-flop. Okay, to do that, okay, so nampak ni, kamu tengok ni. Okay, so this is the T flip-flop punya output. Okay, kamu tahu this is your T flip-flop punya output. T, Q bila kosong, Q bila 1, Q bar. Which is kamu boleh find out from here, kat sini. Nampak tak? Bila kosong kosong, Q, 1 1, Q bar. Okay, so what you going to do is, kamu ada JK. Q and this is a Q bar. So why not JK ni kita sambungkan dia bersama-sama. Okay, and then this is your clock. Okay, sambung kepada T. Kenapa? Bila J kosong, K kosong, okay, the output here will be Q. Okay, bila kosong kosong, which is T kosong, the output will be Q. And bila J1, okay, bila kamu letak 1 sini, so automatic J akan dapat 1, K akan dapat 1, Q become Q bar. Okay, so betul lah. Bila T1, Q become Q bar. So this is your D flip-flop and this is your T flip-flop circuit by using the JK flip-flops. Okay, so to implement a T flip-flop, connect both input J and K together. To implement a D flip-flop, okay, the K need to be inverted. Okay, so and then connect to your D inputs. Ada soalan? Tak ada Okay, kalau tak ada kita, sebab kita ada sikit lagi. Okay, maybe yang this one kita sambung next class, boleh tak? Untuk yang asynchronous flip-flop ni.
Boleh.
Okay, kita sambung next class. Okay, and then kita akan continue with our test lah. Pukul 2 nanti. Okay, kita start kita punya test pukul 2.